So in this last webinar, we're going to bring a lot of the theory we've talked about in previous webinars together and talk about the Corda node, Corda apps, and a Corda network. A Corda node is really just a process that runs within a Java virtual machine. You can think of it as a bunch of services that's backed by a SQL DB for a persistence layer and has an RPC framework for users of the node to interact with it, and a messaging service for it to communicate with other nodes on the network. Nodes can support custom functionality, and that custom functionality is called Corda apps, and that's typically what Corda app developers will be producing. So they'll be building their own Corda apps, implementing custom functionality that can be used on a Corda network. So it's easier to visualize what a Corda node looks like, and we have a diagram here. You can see here that the node is this large grey box in the middle. It implements a bunch of services, and those services will group together with this internal object, and it contains references to the vault, and that's where all states which are relevant for this particular node are stored. Then there's the transaction storage, which you can think of as just a key value store where attachments, transactions, and serialized state machines are stored. You have the state machine manager, which manages the operation of your flow state machines. We have identity and key management, so that's how you can manage the various identities which your node can support, as well as keys which your node can generate that can be used to sign transactions. So scheduling service for scheduling operations at some point in the future. Then we also have network map and notary. So these are optional services that your node can offer. Remember at the beginning when we discussed the Corda node, that the network map is essentially just a phone book of all the nodes on the network. This network map can be used to look up nodes by their name or look up nodes by their key, for instance. Then, of course, you can have a node that can serve as a notary service or serve in a notary cluster. And then we have a messaging service, which is an interface to the message queue messaging layer. And that interfaces with the other nodes, and we have various numbers of these services persist their data to the SQL DB, which sits under the node. There's a subset of these services which are offered to Corda app developers. So firstly via the service hub, which is what developers get access to via the Flow framework, and also via Corda RPC Ops, which is the implementation of the RPC server, which RPC clients can connect to. What developers do is they would attach a web server to the RPC client, and they would serve data from their Corda app via a web server which connects the RPC server via a client. What Corda app developers do is they produce a Corda app which comprises flows, contracts, states, and services. And a Corda node can support many Corda apps. They can also depend on each other as well. But typically the majority of the Corda app involves building states, contracts which govern how those states operate, and flows which contain the main or the core business logic for how those states should be used on the ledger. So that's probably really the best way to visualize how the node looks from a developer's perspective. So now we're going to look very briefly at what happens when a request is sent to the node. Let's imagine here that there's a hypothetical Corda app already installed on this node, and it has an RPC interface and a web server that's serving a user interface as well as some data that's derived from that Corda app. Let's say we want to make a request to start a transaction to maybe reach an agreement with another node. We would do that through the HTTP API, and through the API we would call the RPC server through the RPC client, and what we would do is we would start a flow. So if we want to do anything in Corda, we have to do it via a flow. The flow contains the business logic required to access the node services, create a transaction, verify a transaction, etc. So typically what we'd do when we start our flow is we'd build our transaction, verify and sign it. We would do this via the first steps of the flow. We would need to receive a signature from our counterparty. So what we would do is we would send a message to our counterparty via the network. They would sign. Let's assume this is a happy path scenario where they would always sign. Then they would send their signature back. We would potentially perform more steps. We would check their signature, for instance. Once we're happy with that, we would then send the transaction to the notary service for signing so we can achieve finality, and then we would receive back from the notary a signature. We would attach that signature to the transaction and then record it in the storage service. So all transactions are recorded in the storage service, which is a key value store. Only the relevant output states of a transaction are stored in the vault. Now, you can think of the vault as the vault maintains the subjective view of the ledger for this particular node and its users. Once the data is in the vault, then via the HTTP API, we can make a request. We can extract that data from the vault and display it in our user interface. You can think of this as a life cycle of making a request to start a flow to reach consensus about a shared fact, and then store this shared fact on the ledger. So both parties to this flow would have an identical copy of the output state to the transaction in their vaults, assuming it's relevant for both of them, which it probably is. Then this state can then be extracted from the vault via a query and displayed in a user interface. So that's typically how a Corda app would interact with the Corda node and users of the node. Lastly, we're going to briefly look at a Corda network, what a Corda network comprised of, and what each of these components do. Very simply, network consists of some nodes, and they communicate using AMQP over transport layer security. We have a permissioning service as well, or what we call a doorman, and this doorman automates the provisioning of TLS certificates. So to join the network, you have to obtain a certificate. We also have the network map service, which is essentially the phone book that publishes information about nodes on the network, and we have one or more notary services and 0 or more Oracle services. So those are literally the entities that would comprise a Corda network. So we're just going to go into a little bit of detail about the permissioning service and the network service. So we've already talked about notaries and oracles and Corda and regular Corda nodes. You can look at a network, something like this. This is the same diagram that we looked at in the first webinar, except now we've annotated it with some details. So in the network map, you would have a listing for each one of these nodes, Alice and Bob. The entry in the network map service would also list what services they offer. So for example, Alice is a cash issuer and a bond issuer, as is Bob. They would have the address by which they can be communicated on, as well as the public key which other parties can use to verify transactions which have been digitally signed by them. Then of course we have a notary node, and this notary node, it just looks like one single node, but of course that's just an interface, and it could be comprised of multiple nodes or cluster of nodes operating in consensus. So the permissioning service is required on Corda because Corda is a permission network, and is expected that for an entity to participate on this network, they would sign a network agreement and obtain a certificate from a root authority, the permissioning service. So on the current testnet, certificate signing requests are reviewed by an R3 team, and the R3 acts as the root CA for the testnet. And once you have this certificate, you can place it in your nodes folder, and your node can now connect to the network and communicate with other nodes on the network. In the absence of a certificate, you wouldn't be able to communicate with the other nodes. The network map service is pretty simple, really. It's just a list or a table of all of the nodes on the network, and periodically as new nodes join the network or leave the network, it would publish their data, so it would emit an update to all other peers. It's worth noting that any node on the network can act as the network map service, though typically you would just have a dedicated node acting as the network map, and this network map is distributed to all peers, and they keep a cache of it called the network map cache on their nodes. So interestingly, actually, if the network map service does go down, the only thing that it prevents is new nodes joining the network, because all other nodes maintain a cache of all other nodes that they know about on the network. If the network map cache does go down, they can still rely on their local cache. So that's it, really. You can just view the Corda network as a bunch of Corda nodes, as well as a permissioning service, a network map service, a notary, and potentially some Oracle nodes as well.